run in a virtualized way. And today, it's also happening, but mostly these functions are deployed in the central DC. So when you think about the entire footprint from of the service provider, from the access aggregation to the central side, right now most of these functions or applications, they run in the central DC. And there have been multiple challenges of adoption of the NFV, but I will simply skim through that in the interest of time. We'll have more topics to cover, which are by far more interesting. Another driver for evolution of SPDC are actually, it's all about the application. How SPs, what type of applications they want to run in the NFV environment. And even if this list of applications or use cases, they seem to be very different, what is common between them is that most of them require low latency. I mean, from the client, from the endpoint, to the moment when you hit the application stack, the latency must be bounded. So right now, in the slide back, I said that applications are currently being deployed in the central DC. So it means that the packets, the traffic has to go from the endpoint, all the network up to the central location where the application runs on. If we assume that there are some certain use cases, certain applications that require low latency, it means that we have to think how to make the applications to move deeper into the network, how to make it to work at the edge or at the far edge. And there are certain developments on the way the applications or services are running that help us to make this decomposition and placement of different functions in different places in the network. Think about the virtual packet core, especially in the context of CAPS, where we separate the control plane and user plane. So these functions, until recently, they were always deployed in a single location, single box, bare metal appliance that was sitting somewhere in the network. We can decompose that. We can think about the control plane function and the user plane function. And if it can be different applications, different functional blocks, if we can put that in different parts of the network, we can suddenly achieve some level of optimizations and get low latency from the user to the moment when we get the traffic from the user. And that also is applicable in some way to different types of applications that are driving the entire NFV types of solutions. If we assume for a moment that we want to run these applications not only in the central DC, but somewhere else, and the question is where? And SPs have already a lot of places when they have different equipment, pretty much traditional routers. So there is a trend, a term which is called CO transformation, which simply means that the locations where SPs have already their own equipment for different use cases, it can be repurposed or reused to also run a small data centers. So think about like this. Right now, we might have in SP environment 2, 3 big data centers. If we stick to this logical, hopeful explanation that there are some drivers to make low latency services, there are some reasons to think about deploying some applications, not only in central DC, but also in edge, in different locations, we get to the situation where we end up in potentially multiple smaller data centers deployed across the network, not only in the central site, but also at the edge and at the far edge. And that's actually in the cornerstone of the SPDC evolution. We are talking about the multiple DCs, big or small. So what will run on these data centers? What will run on these compute applications, of course, but they might have different way. These applications will vary. So if we think about the virtualization stack, it will be mostly OpenStack. And right now, these days, the applications that are being deployed are OpenStack based. But it's also evolving. We will have a container-based applications as well that will run maybe on top of hypervisor, maybe on bare metal, right? So we might have this mix of different types of applications that will run in different places in the network. So the bottom line here is that if we create these data centers across our footprints in central, edge, or far edge, we want to have the capabilities to run different type of applications on these data centers. If we have more devices, more data centers, more applications, we increase the complexity of maintaining that, of managing that, of keeping the software in sync, keeping the application state in sync. We need automation. Without automation, it's not possible to deploy a distributed data center environment. So these are the pillars. I just wanted to give you some big trends or big technologies which are driving the evolution of SPDC. The fundamental building block of new SPDC or telco cloud is the infrastructure piece. These are the servers and switches that connect the servers to the network, where the VNFs will run on. These OpenStack VMs or containers. That's the infrastructure piece. Think of it as a small data centers, or maybe medium, or maybe large, depending on the use case, depending on the location. This market is very heavily driven by ETSI. So when we talk to service providers, when we position the telco cloud, very often we get the question how that maps to the ETSI NFV reference architecture that was laid out a few years back. I'm not sure if that diagram looks familiar to some of you, but just to get through that quickly, what ETSI has defined, they said that there should be a common infrastructure layer. Think of it as servers that has a virtualization layer, so we can run virtualized applications on top of that. We need to have a virtualized infrastructure manager which will manage this infrastructure, and on top we have the applications which may require their own VNF manager that will manage the lifecycle of the VMs. And on top we need the orchestration piece. So what we call the infrastructure is really exactly this bottom part of this diagram that I will talk in a moment in a few slides. But I will also go up. I will also have the orchestration section where I will explain what type of products and what solutions we have in the space of VNF manager, Mano, what we have in the context of Mano, and what we have in the context of orchestration. So I will cover the products across this stack. Whenever people want to build the NFV infrastructure, there are different approaches to do that. And NFV infrastructure seems to be easy. It's as simple as getting a few servers and connect them to the infrastructure, but that's not that easy. You have to make a lot of choices. What type of hypervisor you will take, what type of operating system you will have. If you want to take OpenStack, who is the vendor? Is it Red Hat? Is it Canonical? Is it Mirantis? When you go to containers, there's also plenty of choices that you have in front of you. Which framework I will select? There are loads of open source components in it. You want to get the logging, how to get the logging, how to do the monitoring, how to do the virtual switch. It's a very complex. It's a jungle of different technologies. My message is that there were people a few years back, SPs namely, who believed that they have the manpower, brains, skill set to do what they want and control their own destiny. So they were thinking, I have this NFV topic upon me, and that gives me the flexibility to pick up anything I want, any hardware vendor, any hypervisor vendor, any SDN controller, anything and everything, and I want to become myself. I want to control my own destiny. I want to create this ecosystem. I want to make it to work. We call this do it yourself, or maybe sometimes solution integration-led type of deployment. There's nothing wrong in that. There are a few customers that were successful in that journey, but not many of them. I think that it's fair to say that right now the market is more evolving into the more vendor-led approach, where the vendor, like Cisco, of course, but let's be honest, there are also other vendors there on the market, Nokia, Ericsson, Huawei, who are playing almost the same game, right? we want to offer a common infrastructure layer for the service providers that will be easy to use, easy to manage, open for different VNFs, because we cannot lock SP to run a Cisco only VNF on top of that. That's no go, right? It has to be open for the applications that runs on top. That's why in this diagram we have different types of VNFs, maybe even different types of orchestration components from different vendors that will run on the common infrastructure. And there are several benefits of that approach from the service provider perspective. There's also a solution in the middle. I call that vertical use case, but I call that still a box. So what this solution in the middle is all about? Think about the packet core use case from vendor A. And that vendor says, also Cisco, to be frank, we have also such solution. We say, we run right now packet core on a virtualized way, but we don't sell you that as an ASR 5K box. We give you a few servers, but don't touch them, right? I mean, these are the servers only for that use case. So that, for me, is still a box. It's not an infrastructure, right? It's a box that doesn't look like a bare metal appliance. It looks like servers, but it's only there to use for one specific use case. And again, there's nothing wrong with that. There are moments, there are places where this is a good approach. But what I will be talking more towards the end of the session is the solution on the right, where the goal is to have a common infrastructure layer, common virtualization layer, where we can run VNS from different vendors and orchestrate that and orchestrate them. So what NFVI as a product is a combination of software and hardware that will allow us to run different VNFs, and that's what this picture is all about. At the end, this cloud, this infrastructure starts with the hardware in the rack at the end. So what's in the rack? In the rack, we have servers that might have different function in this cloud, and they have to be connected to the data center. So we have top-of-rack switches. We have two of them. We have two of them because we want to have high availability. If one top-of-rack switch goes down, we still have connectivity to this cloud. There is a management node in this cloud as well. It's more like an undercloud. If you are familiar with Red Hat's concept, there is one special node in the cloud. It's not basically undercloud. It's our own way to do things. But maybe some of you are more familiar with the Red Hat's let's say terminology. It's a special server in the cloud, which is like a jump host to all the others. From this server, we do the installation. It's a special one, but it's not carrying any data. And then we have controllers, storage, and compute. Maybe show of hands. Who in this room comes from the virtualization background, knows about OpenStack and virtualization? I see only a few hands, but so in the context of OpenStack, you need to have some sort of control points. You need to talk to the system to ask to do something, create me a VM, do something, right? That's where you talk to these controllers. We have three of them because they need to be highly available. We need to have a storage because the images from which the VMs are running needs to be somewhere on the disks. Think about the database. Database needs a file system. You want to have this data persistent, right? That's why we have a storages and we're full of disks. Compute nodes is where the VMs are actually running on, right? So that's on a high level, the components of the Cisco NFVI pod. And now, remember I told you before that we want to have this solution being capable to be deployed in different places. It can be positioned in the central DC, can be somewhere in the middle, can be even in the far edge. And that's why we have optimized, we have different ways to size this deployment. It can be a relatively big cloud, things on the left, where we have dedicated controllers and storage. This system can scale up to 128 servers right now. It's several racks of equipment. Think of it as a big cloud, big capacity, a lot of disks, a lot of CPUs, and you can run multiple VMs on top of that. But such deployment will not be good if you want to just run a handful of VMs somewhere in a different location, right? So that's why we have optimized that from the product perspective, and we can deliver the infrastructure piece, the NFV piece, in different form factors, if you wish. It can be as small as 3 servers with +1 management server and top-of-rack switches, right? So not much equipment in terms of the footprint. But still, these servers are very well ready from the software perspective, from the infrastructure perspective, to host at least few nice VNFs if you want to put them in the location where you just need to have few of them. Regardless of the fact how this cloud data center looks like, it's a common management layer, common software, common everything, right? It's just the fact that you can optimize your deployment according to your needs. So we are evolving from the product perspective into different directions. Sometimes we have the need to have a big deployment, central deployment, a lot of VNFs. Right now we are at 128 nodes. Maybe we will get more over time. We need to get the need for that from our customers. At the opposite, at the flip side, we can go also very, very small, these 4 servers, etc. And we can also have something in the middle. I also mentioned that the applications, because it's all about the applications. No one will build the data center just to take the power, right? We need to run applications on top of them. So what is the application? We have started our journey on Cisco and AVI with the applications which work on top of OpenStack. So if I was not clear yet, I will repeat that once more. It's all about OpenStack. Yes, I acknowledge there's also a VMware piece. We have different solutions in Cisco for VMware called HyperFlex. But in the context of Cisco and AVI, what we position for telco operators, for telco cloud, it's OpenStack-based deployment only as of today. So our first shipping approach was to deliver the common infrastructure for the OpenStack VNFs to run on. Think about the virtual packet core. But Luis was talking today a lot about the cloud CMTS. It has nothing to do with OpenStack, right? It's all about the cloud native and containers. And that's also happening in the packet core as well, right? So that's why we are evolving our solution to also have containers on them. So right now we are somewhere in the middle. We are somewhere here where we can run containers on top of VM for some specific technical reasons. But if you think about what will happen in half a year from now, think about like this. You have these few servers in the rack, and you can kind of say, these 5 servers are ready for OpenStack VMs, these 4 servers are ready for containers, and these 2 are ready for bare metal workloads using ironing. So we can mix and match. You can consume your cloud the way you need and the way you want, right? Common infrastructure, same servers, same operations, same automation, and flexibility in running different workloads. We are not there yet. Right now we can run OpenStack containers, bare metal workloads, ironic, and we can run containers on top of VM, but very soon, hopefully, we will get to the moment where we will have full flexibility in the context of type of the workload, okay? Sure. No, no. You mean on the so when if
Sorry, guys. Excuse me. Kari, could you please repeat the question just for the...
So the question was about if we evolve towards the OpenShift type of platform. I think that from my understanding is that you will not find OpenShift easily in our solution anytime soon. When you think about the things on the right, we will have the common hardware and software maintenance piece. And like I said, you will say these servers are for this or that workload type. So when I said bare metal, I mean really ironic, right? So we have the way to add a server, and then what runs on top. You know, it could be OpenShift, but we'll probably not be orchestrating that automation piece with OpenShift, right?
So it'll still be OpenStack APIs.
Yes, yes. OpenStack and also our NFV infrastructure APIs. Because yeah, it's a good question, and so maybe let me try to say that that our Cisco Vim, our NFVI, it exposes its own set of APIs in the context of how to manage the infrastructure, how to manage the hardware. If you want to trigger something like software update, you will talk to our management platform saying, please update this NFVI pod from Newton to Queens. If you want to add a new server, if you want to add a new storage server, if you want to remove something, if you want to reconfigure something, our system is fully RESTful API ready. So you will talk not to OpenStack, not to Kubernetes, but you will talk to our API that manages the infrastructure piece. And then you will talk to OpenStack APIs to bring up the OpenStack VMs. You will talk to Kubernetes to bring up cloud containers, right? Etc., etc. So it's a multiple levels of different APIs that are exposed from the platform. And the reason why we are bringing these different types of form factors and of Cisco NFVI is really to be flexible in the deployment models. Because like I said, depending on the location, depending on the VNF type, we can always position the big full pod. But remember maybe the picture. Full pod means 3 controllers, 3 storage, 1 management. If all you have is a VNF that is worth 2 servers, your overhead is huge. I mean, it's nice, but no one will buy that. No one will really want to deploy it. That's why we can optimize the footprint, optimize the size, and also optimize the cost to run smaller number of VMs, smaller amount of cloud-native applications on smaller footprint. That's the reason behind us productizing different types of pods. Again and again and again, even if they are different components, they have a common management layer and a common automation layer. So how you can connect these servers, these NFVI pods, these small, medium, or large clouds into the network, into the DC fabric, into the network areas, into the WAN. There are different options to do that. I think that Brian will have a bit more on that topic tomorrow, so I will not spend too much time on this slide. But right now, I just want to highlight that we are also flexible in our solution to connect for different deployment models. It can be, for example, the solution where we connect servers straight to NCS 55K type of router, right? And then we go off to the network immediately. And that might play well if you put your servers somewhere in the edge, in the far edge, where you don't have any real data center, where you don't have ACI, where you have your MPLS segment routed core, and you just have your small VNF that requires few servers to run on, and you want to connect them straight to the network, kind of, right? So you don't want the overhead of additional switching layers. You want to connect these servers straight to the NCS 5K that you can repurpose for the network connectivity as well. If you are in a different place of the network, where you have your data center fabric, that's when you will have top-of-rack switches connected to the spine layer, or maybe even bigger architectures where you connect that to leaf and spine. So that depends, but the flexibility is there. The same type of flexibilities we have when it comes to the virtual networking and SDN controller support in the system. We start with the hardware, we start with the software, and then we can configure, then we can install different virtual networking types in such pods, depending on the location, depending on the preference, etc. For example, if we deploy NFVI in the big pods and we connect these data centers to ACI Fabric, we have the solution where you can integrate OpenStack with ACI. Sometimes it will play well, sometimes it will not play well, right? Sometimes you may want, for example, to connect them to a data center fabric which is not ACI ready. So you just want to connect them using the virtual switch, and you will have some VLANs from your top-of-rack switch to your data center, right? The choice of virtual switch is also important. If you are from this world, you know that the VM connects to a virtual switch, and then via the physical link, it connects to the top-of-rack switch. And there are different choices here. You might go with Open vSwitch, which is typically considered good enough, but not fast enough. You can combine that with things like SRIOV, which means that you want to bypass the switch, bypass the virtual switch to get more performance. We also are supporting the VPP, which is our own development, also open source as FDIO project. VPP, who knows about VPP or FDIO? Okay, few people at least, right? So this is a DPDK friendly Cisco developed virtual switch that you can use to achieve better performance without the need of SRIOV. So we have different options in the context of virtual switching, in the context of SDN controller. We can integrate with VTS, we can integrate with ACI. That gives you potentially a good flexibility on how you want to actually run your virtual functions.
You are the only participant.
I'm the only one. Good. I'm glad that you are here in the room. Yeah, where I was at. Yeah. Okay. So, but let's make no mistake in the sense that everyone will have some installers. Everyone will have probably the same kind of pitch. Yes. Sure. Sorry.
I have a question here in the previous slide.
Yeah.
So we have 3 deployment options, if we can say, for the SDN, either the vanilla SDN or using BTS or the ACI option.
Yes.
So mainly for Cisco, I am talking about the VTS and ACI. Which one we can choose according to the requirements of the specific customer. So you now have 2 different products with 2 different solutions, the VTS and the ACI. Which one I can position, or how can I select each one of them in different options?
Yeah, I think we have always the same type of challenge. I mean, you know how Cisco works. We have quite often multiple solutions to the same question, right? And I think that it will depend. I think that's the best answer I can give you. In some cases, you might see that ACI pitch, ACI approach is the optimum for the customer because this customer has already ACI, or maybe it's ACI friendly, so why not to position ACI, right? But you might also be in a completely different place where you see that ACI topic is hostile. It's something that it will not go well with the customer, right? There are some customers that don't even ask about the SDN controller, right? So it really depends on which option you will take. I don't think that it's an easy answer. Always go with this, or always go with that option. For example, if you want to deploy a micropod, a small pod, deep in the network, where you just have your network connectivity like MPLS or segment routed, probably you will not go with ACI, right? You will say, in that context, maybe it's better to connect your small data center straight to NCS 55K, so we can do it in a different way. So I don't know if that answers your question. And maybe we can have a chat. I will show you different designs that we are having with different customers, and then double click on why we went with this approach or that approach, case by case, because it's really case by case type of decision that you have to make. I was counting on you, Brian. I was sure that you will enter. So go ahead.
I think with APIC ACI, it's when you're very concerned with the underlay and overlay and wanting the 2 tied together, and you really want to push policy from end to end. VTS was very much when you're only concerned with an overlay based model. So you don't really care that much about the underlay. So they're kind of very high level. That was the difference between those 2 models. But as Carly said, what you'll see, and we'll talk about it tomorrow, APIC is very much where we're going from very centralized large-scale policy. You'll see tomorrow that we're now looking at a thing called network data centers and network-based and SR. So where we're really pushing towards is how do we get a controller for SR in that environment. So there is a slight change of orientation. Again, smaller overlay versus large overlay and underlay.
Thank you, Brian. Yeah, question. Yeah. Okay.
Okay. For no SDN network connectivity support OVS, VVP, SRV for ACI. I think he integrate with OVS.
Yeah.
ACI support VBB and SRV.
Yeah, there. Yeah, if you take a closer look into the real support matrix, as we sometimes call it. This jungle of what works with what. Right now, if your preference would be, I want to leverage the ACI and I want to integrate Cisco Vim with ACI, your only choice today is OVS or OVS with SRIOV if you need a lot of performance. The virtual switch like VPP is not yet integrated properly with ACI. Now, it doesn't mean that you cannot deploy the NFVI with ACI on top. And that's a blurry topic because you still can have your ACI fabric. Sometimes we call that ships in the night. You have your switching, virtual switching, you have your ACI. And if you know that where you will place your VNFs, what these VNFs are, how they connect to the top of rack switches, these are not dynamic VNFs. Think about the packet core, PCRF, well established. Deploy once and use for a long time. So you know where these components are. You can kind of plumb them manually between ACI and NFVI. And there are some customers that do this way. So nothing prevents you from even using VPP on virtualization layer with ACI on top. But these two islands will be not integrated. I mean, they will not talk to each other in a way, if you see what I mean. But we are getting there to also support VPP with ACI integration. It's just a matter of time for us and some natural steps.
ACI support OVS if some application need SRIV. Can I mix and match?
Yes.
Okay.
Yes. Yes, you can. And you can also do things like if you have big rack of equipment, SRIV is cost. Let's be honest. You need to have a line card, you need to have a NIC, you need to have a wire, a cable, right? So if you have a big rack and you want SRIOV, you can always put an Intel NIC and ports only on, let's say, 5 out of 20 servers. And as long as you remember that these are 5 servers that are SRIOV ready, you can always place the VNFs that require SRIOV only on these 5 servers and keep the 20 others without any SRIOV capabilities. So the platform is really flexible to use what you have in your rack, let's say, right? Okay. So I think that everyone on earth will have something like installer. If you have an OpenStack, you need to install it, right? But what's really for us in Cisco, and what's really, I believe it's special in the context of Cisco Vim, is how we manage the day 2 operations. Because installation is your first step, but then you will maintain this platform for hopefully a much longer time. So we deal with a lot of things like software will evolve, and it evolves quite quickly. Kernel will change. OpenStack releases are changing. The packages are changing, right? All of that is evolving from feature perspective, from bug fixing perspective. Your hardware might fail. Think about the situation where you have your cloud, it's production grade, you have your customer traffic on this cloud, you have 3 highly available controllers, one of them goes down. Physically goes down, and you need to have a new one. You need to replace controller with the new controller. You want to take the new box server from the box, put it into the rack, wire it, and make like this. I want right now this failed controller function to be deployed on this server. Same for the cloud sizing. You want to increase the cloud capacity. You want to add new servers. You want to add storage. You want to add disk. This is what I refer to as day 2 operations. And that's where we have put a lot of development and a lot of effort to make that seamless, to make that production grade, right? And we have several examples from the real deployments that this is not just a slide, this is the reality. The customers, we have a customer in Japan, entity that I will talk in a moment, that deployed this infrastructure in 2016. That's ancient history, guys, right? 3 years in this industry, it's ancient history. And they are going with us step by step, release by release, growing the cloud, and in the production, environment. So it's not about being arrogant, but I just want to emphasize that these are the topics or areas which is for us of the key importance and the value of our system as well. So you can manage pod by pod, but what if you have 20 of them? What if you have 30 of them? Even 10, right? You want to have, maybe you want to have a single place, a single management station where you can say, okay, I would like this person and that person to have the right to manage these pods the edge pods, and I want the different people to have the right to manage different pods. I want to have a one point of maintenance of your entire distributed cloud. These data centers, these NFVI pods, they might have different virtualized networking options. They might have different version, right? Even because it depends. But you want to have one point of control, and that's why we have the unified management for that allows you to control multiple pods from the central location. We are heavily evolving on this one, also in the context of monitoring and metrics collection. Because as soon as you deploy your cloud, your first question is it working? Is it healthy? And that's not only the question that you ask when you install it. You constantly want to ask this question: is my cloud operationally healthy? Does it work? And think about like this: you might have a system which has 60 servers in the rack. 60 servers. On every server, you might have multiple containers for control plane function, for virtual switch, right? These are real Linux operating systems. They have their own memory. Something might go wrong. Memory may be saturated. So you want to have a mechanism to check this complex system from multiple perspectives. Busy slides, so I will try to do it step by step. One component to check, for example, is my OpenStack healthy? Is my OpenStack cloud working correctly? We have the component called Cloud Pulse, which is running constantly the real OpenStack type of tests against the cloud to make sure that the cloud is operational. We want to gather the logging in a single place. Again, it's a distributed environment. We have multiple servers, multiple components. For those of you who are from OpenStack, you know that you have different OpenStack projects. Keystone, Nova, Neutron, all of these guys are generating logs. Logs that are important for the operators to understand, is my cloud in a proper operational state? So we have the mechanism that we can get these logs over the network from all the servers, and we can monitor that in a common dashboard, right? So we can see what's happening with your cloud. Last but not least, you want to understand the state of your servers. You want to understand what is the CPU load, what is the memory load, what's the network load. You may want to have some metrics. If the CPU goes above certain threshold, you may want to get an alarm on your dashboard, right? So that's also what we do in this system. There is a monitoring subsystem which is taking a deep look on every server, and you have the common dashboard where you can gather all this information to understand the state of your infrastructure. You can get the logs, as well as you can have the proper view if my OpenStack is ready to be used. And that's actually a fundamental piece of the entire solution: data operations and monitoring. Without that, the system is undeployable and unmanageable anyway. I will skip this slide because it just pretty much summarizes with what I tried to say before, and I'm almost there with the time, I guess. So before I maybe go to almost last topic, maybe a question on what I have said so far, or?
Plus is already in Cisco Vim, or is another component?
No, so actually it's in Cisco Vim. Obviously there are some components which are separately priced on the BOM, but what I showed you right now is part of the entire Cisco Vim stack. So the hardware piece, the software piece, the Cloud Pulse, the monitoring, the log forwarding, Kibana dashboard, all of that is a part of the entire ecosystem. All the data operations, the management station, all of that is part of what we call loosely a Cisco Vim.
You mentioned that we can have unified management for multiple pods, even this in different geographical locations?
Yes. Yeah, because there was a question before about the RESTful API. So think about like this. Everything that you do with the system is REST API. It's DevOps friendly. So if you want to check the state of the system, you launch a REST API call. If you want to change the state of the system, you launch the RESTful API call. So we can do it manually, but you can also do it from the management station. As long as management station has the API access in the, from the IP perspective with all the pods that you have there. If that's the case, you are good. Okay, so now we go to a another abstraction level. I spoke. How much time I have? Because I'm lost with these breaks and power outages. So how much time I have? I can talk about that for a long time, but I will 15 minutes. Is that okay with everyone in the room? Yeah. So we have covered the infrastructure piece, right? Servers, how to install that, where to install that, how to bring the OpenStack to work, how to bring the container platform to work on that, how to manage the life cycle from the cloud scale perspective, adding new compute, adding new storage, etc., etc. All of that is very important. But what's really important next is we want to run applications on that. So how I can bring the applications in OpenStack or in containers? A bad way to do it is to go and do it via the CLI. It's doable. If anyone in this room has done it once in your life using Horizon Dashboard or OpenStack CLI, yes, it's doable. You can do hit template, lots of ways to run the application on top of the infrastructure. But think about it from different perspectives. You might have different data centers, small or big, and you want to automate that, right? You don't want to do it in a CLI way, right? So that's where the automation piece is actually becoming very, very, very important. And we have two products in that space from the product perspective. One is Elastic Services Controller, and the other is NSO. And I will right now try to double click into these two products to understand what they do differently from one another, when it makes sense to position them in combination, and when it might make sense to just position ESC as a single entity, and that's it. So I will just skip to this because I will come back to it. So about ESC, again, Elastic Services Controller. Think about as an application. So if you are interested in that, you go to CCO, you get the image. What ESC does? ESC is responsible for deploying VNF. What is VNF? VNF is either one VM or more VMs connected in a certain topology. And you want to deploy that in your infrastructure. Deployment of the VNF in the infrastructure, sometimes it's easy, sometimes it's not, because you may want to control the boot order of those VMs, affinity rules, so you may want to put some VMs on the same compute, or quite the opposite, you may want to put them in different computes. You want to push the day one configs to them so they can boot from some configuration. You want to monitor them, because what if the VM dies? What if the compute server dies? What OpenStack will do? Nothing. If compute node dies, compute node dies. If the VM dies, VM dies, right? OpenStack is not really aware about the state of the VM itself. So ESC is the application that is receiving some requests from the top, be it script, be it NSO, be it human being. Please deploy this arbitrarily complex VNF on this cloud, And it will decompose that request to multiple OpenStack API calls. So it will kind of do this horizon clicking or OpenStack CLI to deploy multiple VNFs on top of the infrastructure. And then, important topic, it will monitor these VMs. Monitoring of the VM can be very basic, can be just as simple as ESC will ping every VM in the VNF to see if it's working. If it's working, doesn't mean that it's really working, but at least it's responding to pings. But it's better than nothing, right? And if it does not, ESC will try to recover that automatically, right? So that's one big things of the ESC. Monitoring, which is pretty much combined with healing and fault recovery. Elasticity, that's why it's called elastic. It's linked to scale. Think about it in the following context. You use ESC to bring a web farm, web servers. You bring, for example, 2 of them. That's your starting point. And then you ask ESC to constantly measure the load of these servers. So how to measure the load of the web server? Well, it varies, right? You can maybe use some REST API or maybe some script to log into the device, check the number of HTTP sessions. I mean, it will be dependent on what you want to measure. What's your application? Does it a web application give you some API? Maybe it has an SNMP. Depends. ESC is flexible enough to accommodate to different environments. Long story short, you somehow assess the load of the application. And if the load is exceeded, you can ask ESC to bring up a third or fourth VM in the same, let's say, you can size your deployment, kind of. And then if the load goes down, you have a second threshold which will say, okay, enough is enough. I have 4 web servers running, but I only need in practice 2. So ESC will kill 2 of them and leave the other 2 working. So that's the elasticity component of the ESC. ESC is very flexible. I'm spending my life on onboarding different VNFs from different vendors. I have never seen any single VM that I cannot onboard with ESC. I mean, because if VM can run in OpenStack, ESC is also sending OpenStack APIs. That's all it does in the context of onboarding, right? So if you can deploy the VM, you can also onboard the VM via the ESC. So some customers, they acknowledge that ESC might be their what we call GVNFM, generic VNFM, a common lifecycle management for VNF, be it Cisco, be it whoever else, right? I don't want to oversell that neither. There are some cases where it makes no sense to integrate the VM, but that deserves a more deeper conversation. But when you think about the ESC as a product, it's very, very flexible. By the way, it also supports VMware and also supports Amazon Cloud. I am more concerned about the OpenStack because that's what NFV infrastructure product is all about. But as an ESC, if you think about that, it's also capable to talk to VMware hypervisor and Amazon and Amazon Cloud. So just for you to understand the product in its, what it is capable of. We are also enhancing ESC to support in a smarter way distributed infrastructure. Remember when I told you that ESC is checking if the VM is alive? So imagine that you deploy one ESC in your central DC, and that ESC will deploy the VM in multiple data centers. So what you want to have? Do you want this one ESC pinging across the network all the VMs deployed out there? That's what you can do. But you also can kind of separate out the monitoring component of ESC and in a smart way deploy it in multiple sites. So the brain, the ESC manager, will say to the remote monitoring component, please right now monitor these locally reachable VNFs, and if something goes wrong, go back to me. So this is simply saying we are ready to make ESC deployment cost optimum in a highly distributed environment where we have multiple data centers. You don't need to deploy ESC on every data center, if you will. So that's why we make this feature in our roadmap. I guess you have a question or no? No. Okay. 5 minutes to go. So I will talk about the NSO in a moment. Who is familiar with NSO as a product from Cisco? Yeah, NSO, thank you. NSO is a network services orchestrator. It's basically the product that comes from the era of non-virtualization. NSO is from TLF acquisition. That's the orchestration component, which is capable to configure devices. So the classical use case for NSO is to configure devices, where by device I mean a router from different vendor, a switch. NSO is exposing the service model. Think the classical use case for NSO is, for example, L2VPN or L3VPN. You want to deploy such service in your network. To deploy L2VPN, you need to configure 1, 2, 3, 4, 5 devices. But L2VPN can be abstracted in just few parameters. I want the service from point A to point B, and maybe some other parameters related to quality of service. So NSO was abstracting that as a service construct, and it was translating that request to sequence of different CLI calls to different devices in the network to push this config and to achieve the goal of creating a service in the network. From the perspective of virtualization, if you ask NSO to provision the VNF, NSO will talk to ESC. So that's how this combination is going, right? NSO is not talking too often to OpenStack or to VMware. NSO, when you want to deploy a virtual service, if you have the need for the NSO, then NSO will talk to ESC. And now I will go back maybe to a first slide, because that shows exactly what's the difference between the two. So that's your virtualization layer, ESC will talk to OpenStack or to VMware to deploy certain VMs in your data center. NSO will be capable to push additional service-related configurations to these VNFs to achieve the entire service definition. So that's the split. Sometimes it makes sense to have NSO and ESC. Sometimes it does not. It depends on the use case. It depends what you want to achieve. But in the context of virtualization, it always starts at least with the ESC. This is just a placeholder, just to emphasize again on the openness. NSO, again, it's not originally a Cisco product. They are well established on the market. They have a lot of different, what they call nets. Nets is a network element driver. It's the way to talk with the device. And they are supporting plenty of these devices, and they can configure different functionalities. This is not really related to only to virtualized domain, right? You will find many vendors here who just have the physical type of appliances, because like I said, NSO will configure the physical domain as well as virtual domain, right? It's open. Again, it's open. So the use cases, and then I will close it off. Entity, oh sorry, messed up with the Entity is our first customer back from 2016. The moment when our VMS, MSX type of products for virtual CPE was not yet ready for the prime time. And Entity wanted to have the solution where they wanted to place a virtual CPE in their stack and connect that via some overlay with the physical CPE, so they can apply some additional services in the data center before the traffic goes to internet. Think about the virtual firewall, and this, for example, could be an IPsec tunnel from physical CPE to the virtual CPE. So when you deploy that, you need to, and it was done in the way when they have customer-facing portal. You can really think about, you can order a service from this location, and you can click the button, and then customer portal is talking to NSO. NSO is abstracting the service definition. It's talking to ESC. It is talking to SDN controller. It is talking possibly to different physical devices. All that needs to happen to make this service to work. It will also talk to ESC, and ESC will spin up the VNFs on top of OpenStack. So that's a real service that was deployed many times, quite a long time ago, and it's being used from then on, and it has been on a very, it has been updated from the software perspective at least few times across the last 3 years. So that was our first reference. By the way, I can only show you few references. We have by far more customers, but for some reason, the customers are not always happy to be referenced on the public events. Last Mobile World Congress, we have presented the solution that was co-tested, co-developed between Orange, Cisco, and Samsung, where we were doing a packet core on top of Cisco Vim, 5G-ready packet core that was integrated with Samsung radio, Samsung type of radio equipment, and it was creating a full ecosystem. So it was Samsung radio, Cisco packet core, and some applications with some drone flying around around Mobile World Congress venue to show the video streaming. But that's just a use case that we can also do this. And that's coming from the real deployment. Deutsche Telekom is having a partnership with Mobile HX, and maybe even their company is co-funded by DT. I'm not really sure about the legal relationships between them, but what's the most important, they had a use case for the low latency service. And they said, we want to have a deployment deeper in the network in multiple locations across the country where we want to run a specific application. And this application will require a low latency from the client, from the handset to the application stack itself. That was the main driver for them to go away from the central deployment to the distributed deployment, where they have multiple smaller data centers deployed across the network. And they have run this application on top of Cisco and AVI. It's a production deployment that I think that you can easily find some newspapers or white papers related to this customer deployment in Google, if you wish. Last but not least, a big splash at last Mobile World Congress, Rakuten use case. The customer in Japan, they are going to deploy. Actually, we are already past the first deployment. They are deploying the packet core in a completely different way. They want to have the virtual RAN, virtual DU, and virtual CU deployed deep in the network. So they are having the plan to deploy hundreds, if not thousands over time, small data centers across their entire country, which will run on far edge location, the virtual RAN type of application only. Then if you go deeper in the network, actually here only, you want to run the user plane function of packet core. If you want to go to the central location, there will run things like IMS and control plane function of the packet core. So they are having a different split of different functions across the network. They need data center here, they need data center here, they need the data center there as well. Sometimes small, like here, sometimes medium size, sometimes relatively big, so few racks of equipment. So maybe you remember the slide that I showed you, that we have different form factors. That's how we leverage this, right? This flexibility, but they will still have the common management layer of all this distributed data center infrastructure. Summary slide, but so just to talk about the summary slide, it's all about so SPDC in my eyes is evolving from what could be done in a central locations to a distributed location. That's first. If you have multiple data centers, small and big, you think about the management of them, installation, data operations, log collection, and monitoring. That's what Cisco Vim gives you. Then you need to have your applications, OpenStack VNFs, containers. You need to have an orchestration layer to run these applications in different locations. That's where you have ESC and NSO. And that's all, guys. Thank you.
So thanks, everyone. So now we have our meet and greet event. So Katerina will drive us to the places